Good afternoon. My name is Tesfay Tesfatsion. I work for Sunflower Wellness and Colorado Chromatography. We are based in Denver, Colorado, or Hudson, and our talk will be on safety profile of HHC, THC, and THCP. I know a lot of people don't like the talk about HHC or any of these partial and synthetic cannabinoids, but we wanted to see what the safety is and how we can basically start to incorporate these type of studies into the market to give people the information so they can make their own informed opinion. So today we'll outline introduction, methodology, results, discussion, and then conclusion. So far, through all the literature that we searched, CBD, THC, CBC, there's a lot of information about safety study because of very abundance within the cannabis plant. In terms of hemp products, even Delta-9 THC from hemp or THCP or HHC, very little is known out there. In literature search, we can't really find too many. And a lot of these safety or potency are done through using HPLC and as well as GC. The problem with those is some of the contaminants and some of the impurities are not easily visible. So people assume that they're getting a 99% pure material. In actuality, there might be some impurities that might be in there. And the other thing is in vitro studies are not easily done. A lot of people don't have, one, the money, and two, it's just not understood well enough to be able to be presented. On the side, you can see all the different, isomers you can have when you are trying to convert CBD to THC. There's exo, iso, many different, structural isomers that are not really well known, as well as not easily separated to be able to be used for an in vitro study. This is just an outline of some of the biological testing using MTT assay to be able to determine the amount of cell viability, and then characterization using HPLC, mobile phase, a column as being a stationary phase, and injecting your sample, and then doing a preclinical study. Previously, HHC has been around probably the past 3 years. It has taken over in a lot of states that don't have THC as easily accessible, aka a lot of the southern states are not easily, you can't get THC, so HHC is being a supplement to get people the euphoria that they desire. It's easier to find whether it's gas station or any of those places. The problem is not a lot of people know what they are. So previously, we did a study determining whether HHC has any effect on your heart using a HERG channel or ion channel study to determine to see what is and if it has any effect on your sodium-potassium channel to give you any type of issue with your heart. What we found was using a positive control, we didn't see any inhibition or very minimum inhibition in comparison to the positive control at a very low micromolar. In addition, we also conducted fibroblast cytotoxicity just to see how that affects the lungs. And from there, we did see a little bit of cytotoxicity. So just like a lot of cannabinoid or a lot of other compounds, there is some cytotoxicity to it. In terms of the hepatocytes, that's where we see a very low cytotoxicity, even at a higher concentration, at above 50 micromolar. So this is an earlier study that we did. So to determine, to make sure that, hey, one, the product is safe, and two, the information is out there so that people can make their own informed decision. In this, presentation, we used NMR as a way to determine structural using 500 megahertz. HPLC, again, the standard way of determining potency and purity. We did an Agilent 1100 as well as a Shumatsu as a secondary checkpoint. The CRMs were purchased from Cayman Chemicals, and then solvents, ACS or HPLC grade, and then We try to collaborate with a lot of the industrial players, Jonesy Lab, Arvada Labs, and e-commerce, that we purchased these materials with the understanding and letting them know that, hey, we're going to conduct this type of study, so we want to get as many people as possible so that way we can put all the information out there. The cell viability assay was conducted with HB Biosciences. So 3 cell lines were utilized. In this way, we can mimic the 2 ways that cannabis or cannabinoids are, consumed by us. One of them is using small airway, so inhalation, to mimic somebody smoking, vaping, any of that way to get the cannabinoid in their system. The other way is through the liver, as in using it as a edible, so to get both effects to see cytotoxicity both in the lungs and in the liver. The cell lines, the human small airway epithelial cell line, as well as the human fibroblast, and then the THLE3 transformed human liver epithelial cell. All studies were conducted under non-GLP. This was all ran at a third party to get a no bias and also to get a clear information that is not, we don't own it in terms of the information, or we own the information, but we don't have a bias towards it. All procedures were validated as well as signed off by the place that was conducting this. And the cell lines were purchased by from ATCC. This is just an outline of the MTT assay. Cells were taken, thawed, centrifuged to get rid of the supernatant. The cells was then resuspended and added PBS as well as tryptan blue, and then cells were visualized through a microscope to count it in terms of the viability as well as the how many were apoptotic. In terms of synthetic way, so all the materials were we synthesized in-house as well as the ones that were purchased. Both of them were purified in 2 different methods. One was thin film distillation, and the other was taken as a crude. Utilizing common synthetic methodology, CBD was purchased as is from a hemp company, and then cyclization was done using a strong acid. In this case, it was p-toluene sulfonic acid monohydrate, using a heptane as a solvent. The reaction progresses from delta or CBD to delta 9 to delta 8. Thermodynamic pushes it to the more stable molecule. We took both the distillate and then the crude, removed the solvent in the crude, and used it as is. Similarly with HHC, same way. In this case, THC was taken. Hydrogenation was done with it using palladium on carbon. You can use platinum on carbon. There's multiple different catalysts you can use for hydrogenation with hydrogen and ethanol or different solvents to be able to get your HHC. R versus S, depending on the catalyst that you use, you get different variations and different splits. THCP was fully synthetically made, starting with resorcinol, and terpene, going through a cyclization, free-craft alkylation, and then going through the process of making CBDP, then cyclization with triisobutyl aluminum and DCM, getting D9 to D8 variation of a high D9 to low D8. The HHCs on HPLC were stacked on top of one another just to show the different type of impurities that you can visually see. And here you can see close to almost 8 or 9 different impurities that are in there. Again, this is from 4 different or 5 different companies, so we're not trying to say one is better than the other. It's just showing you guys, hey, these are the impurities that we see, and a lot of them are within the same area that they're coming off in terms of retention time. The NMR spectrum of the crude versus distilled HHC. The one thing to look at in terms of if you want to see the ratio of isomers is if you look at around 3 ppm, you see a doublet and a doublet. You can take the integration of those two and compare it, and you'll be able to see what the R versus S or S versus R ratio of the 2 compounds are. This is just showing you the NMR spectrum of each. You don't see too many differences between them, but HHC is a little bit different because then you're taking THC and you're hydrogenating it. So there's a couple of purification steps that's included in that. Again, same thing with the Delta-8 THC. Again, Delta-8 is not highly found within the plant, but it is when you are cyclizing THC, CBD. Again, you compare it, you see, again, about 6 or 7 peaks that are showing up within the HPLC. And again, olivitol is in there, exo, iso. There's different isomers of THC in there as well. Again, NMR spectrum of it, just to confirm that that is a THC using literature values, literature information that's available. With this THCP, we see almost a twofold increase in terms of the impurities that are present. That is because of the process of synthetically, it is a synthesis, so you can't really find this easily in the plant and trying to extract it. So it is a synthetic process, and some people will not purify each state. They just take one and go to the other without doing any purification. And then towards the end, if you have any impurities that are carried from the first step, those will be carried out throughout the whole entire thing, and it becomes difficult later on to try to purify them. So some people just sell the material as is and say, hey, it's 98% or 96% or 95% purity, but when you look at it in terms of using other methodologies to determine the true potency, you might see it a lot less. But these are not really shown in the market. This is the HPLC potency of each of the cannabinoid. We separated them with D9, D8, CBDP, THCP, CBN, HHC, and the different isomers of HHC. Again, a lot of these, if you look at them, none of them reach above 93% purity. So that's a staggering information of, hey, some of these materials that say that they're 95% cannabinoid, they're not really 95% cannabinoid. There's other cannabinoids within there or other impurities in there. And then, so we just, this is just the breakdown of each of the samples that we got. All of them, we gave them a WC as their acronym, 1, 2, 3, 4, 5, just to give them so nobody knows what they are and information about that. And on the right is the HPLC area count or the milliabsorbance per each. And we can see that even in the WC1, we're seeing olivitol still in there, some exo, some iso, and the different isomers of cyclization that comes from it. Again, same thing. The only ones that you don't see that is if you look at WC9, the HHC, the RNS, a lot of the other materials are not there. That's because of the multiple process of purification that's involved to go from CBD to HHC, having the THC in there and being able to go ahead and do the purification. The problem there is, well, what's the hydrogenation version of the exo and iso? We don't know because not a lot of literature is out there about what happens when you hydrogenate other isomers of THC. And this is the one thing that we want to convey is it's not a matter of, if they're there or they're not. Most likely they're there, but we just don't have any studies that are being done to show what are their toxicity within the body themselves. So using two positive control, chlorpromazine and tafenidine, we ran these assay with HD Bioscience. The 3 compounds, Delta-8 THC, HHC, the RS isomers, and then Delta-9 THCP. So if you look at the first column, hopefully everybody can see that. Using the lung fibroblast, we can see the IC50 of the control was at 14.2 micromolar. And when you look at every other cannabinoid, the Delta-8 in every single sample, everything is below the IC50. So the cannabinoids are cytotoxic to the lungs. Again, this is just mimicking controlled versus that, our compounds. And then when you look at the epithelial cell line for the small airways, we see a consistent, also low cytotoxicity. So the IC50 of the control at 9.3 micromolar, and everything else is way below that. Some of them are in 2 micromolar, so very toxic to the lungs. The other thing that we see is when you compare it to the liver, in the liver cell, tafenidine is at 5.1 micromolar IC50 value. Everything else is anywhere between 3 to 18 times greater in terms of the IC50. None of the cannabinoids are cytotoxic to the liver. So going through a first pass through the liver, these do not cause They might, at higher doses, yes, but within the doses that we were looking at in terms of control, we didn't see any cytotoxicity. So although the contaminants were found within each sample, the preclinical testing resulted in showing that all the cannabinoids had an effect or cytotoxic effect to the lung, the fibroblasts, as well as the epithelial cell lines. Every single cannabinoid, delta-8, and THCP, HHC were all cytotoxic, except for the transfer human liver epithelial cell lines. They were toxic, but not at the concentrations that we were looking at. Everything was above the control. The only thing was the WC16 had a high IC50 values. The reason for that was when we were looking at it, the concentration of material that was in there was about 25%. So it was RS, and total was 25% cannabinoid. The rest of the material, we don't know what it is. So having less cannabinoid was able to show that the IC50 was a lot higher than it should have been. The research underscores the critical need for rigorous scientific inquiries because we want to make sure that all the information is out there, giving people the understanding of what is within the sample that you're purchasing and what you are consuming. Understanding delta-8 THC, delta-4-8 ISO, XO, the different isomers of THC could represent a potential risk for users due to the lack of pharmacological understanding and characterization. The lack of understanding could lead to unforeseen levels of intoxication, as well as the effect that these compounds can have on somebody. So in conclusion, delta-8, HHC, and delta-9 THCP all exhibited cytotoxicity to the lung, both in the fibroblasts as well as the small airways. None of them had a cytotoxicity to the liver cells based on the concentration that we had them running in the sample. That's my presentation. Take any questions if anybody has any.
Hi, thank you for that. Did you guys try to identify any unknown peaks using the HPLC or NMR?
We didn't because we would need to do more purification. We couldn't find a lot of the, CRMs, but within the budget that we had as well as the time that we had, we just wanted to take the samples as they are directly without any modification or adding in any of the other additives that they add so that we could see what the pure material is. And if there's anything added, we could potentially later on take samples from e-commerce with the vapes or the carts and then try to see if that makes any difference. But we did not, unfortunately, were able to do that.
Thank you.
Mm-hmm.
Please welcome TJ Martin, presenting the chemical origins of fruity and savory exotic cannabis aromas.
Acute negative reactions from consumers, were any noted?
No, well, there has been I think it was about 2 years ago, there was FDA had a report of about 20 people who had adverse effect from Delta 8 or HHC samples that were purchased. They weren't really fully understood why, but when they did do a HPLC and also NMR and different potency tests, they did see olivitol still being present within the samples. And other impurities, but those people had adverse effect in order to, even as severe as enough to go into actually hospital and get treatment with hallucinogen. They were throwing up, there was fatigue, and there was a lot of issues that came from it. I don't know if it was dose dependent or what could have been caused by it, but we did see that when we were doing our research.
How do your results for these products compare to Delta-9 products?
In terms of cytotoxicity, it might be my opinion, but it shouldn't matter because Delta 9, Delta 8, the only difference is just it's just an isomer. But we did have some samples that had Delta 9 in them. We just didn't want to do all the studies that have already been done with people from cannabis itself. Since we don't have that type of license, we couldn't really do Delta 9 directly. So it's that legality where if we tell HD Bioscience, hey, can you test this? They might not be able to do it because of the fact that it requires a license for them to carry Delta 9 compounds.
And so if I'm gathering this correctly, it's not the inherent nature of these molecules, but the mixtures that are in them that are fixed?
It can go both ways because there's nothing mixed in there. These are just pure compounds. So if you look at the potencies, a lot of them are 85 to even higher potency. They're not 100% or 99% pure. So there is some little impurities in there. What we wanted to do was, hey, let's take some of these oils that are being sold as being, just pure materials and run them and see what the effect of the compound themselves are. Cannabinoids have been known to cause, cytotoxicity to some, and then some of the other ones are more not cytotoxic, but they don't attack, normal cells. So this was just done so that we can show, hey, the oils that are being sold, that we don't know what they're putting in there in terms of when they're getting them as a pen, but the pure materials, they do have some cytotoxicity associated with them. It's just, we couldn't really do Delta 9 because if you research, you can see plenty of papers that have been done with Delta 9 as being, and their cytotoxicity into it. Yeah. Thank you.